In this module, we're going to talk about transformation. So first off, we are going to briefly go through what the 4 different transformations are that we could see throughout the school year right now. Then afterwards, we're going to go through just the first one, so translations. So transformation, a transformation that does not change the size or shape of a figure, is called a rigid motion. And there's 3 of them that are rigid motions, and that's these first 3. And those are the ones we're going to talk about in this module. So the first one is a translation. The second one we're going to talk about is a reflection. The third one we will talk about is a rotation. The fourth one that we'll talk about later in the school year is a dilation, and that is not a rigid motion. So going back to our translation, we will slide it left or right or up or down. So you're sliding it across your paper. And if you notice, there's the F right here, and then there's an F prime with that little dash on there. And that shows you that this is the first figure and this is the second figure. And we call that first figure a pre-image. The second figure then is the image itself. And just a reminder, what I already said is that the pre-image will just have the regular letters. The image, so after you've moved it, is going to have these little prime marks on there showing you that that's the new figure after you've moved it. So looking on to the next one, reflection is when it flips over a line. So we can see in the second one that the original figure, or the pre-image, is on the left. The image is on the right, so that means it flipped over the y-axis. So it reflected over the y-axis. A rotation, it turns about a point, and the points that we're going to turn it about are around 0, 0 for right now. And we can see that the first image, or the pre-image, is up here at the top, and the image, so the second figure, is at the bottom, and so it rotates it counterclockwise. And we're going to learn more about the different degrees of how many degrees it rotates it, but at least know that this is rotating it counterclockwise. Dilation is a shrink or stretch, or you can also hear it as a compression instead of the word shrink. So we can see that the new figure, or the image, is this second one, our tiny one. The original figure is this outside one. So this is shrinking down. And a dilation is not a rigid motion. On these 4 questions, we need to state the type of transformation, so whether it is a translation, reflection, rotation, or dilation. And then we need to determine if the transformation is a rigid motion. So remember, once we know the type of transformation, that'll tell us then if it's a rigid motion. So does rigid, remember, means that it does not change shape or size. So on this first one, we can see which are the new and which is the old figure, or the pre-image and the image. And we're doing that based on the B and B prime. We can see that it does turn, so notice it's changing in different directions. So this would be a rotation, and it's still going counterclockwise. Because it is a rotation, it is a rigid motion. For number 2, we can see that the original triangle is the smaller one, and the larger of the 2 triangles is the image. That would be the new figure. And since they are different sizes, that's definitely not a rigid motion, so this would be our dilation. And number 3, now I want you to fill this one out on your own, so tell me what type of transformation is it. You've got 2 left. It is either the translation or it is our reflection. And you should see that it did flip over this x-axis, which means it is a reflection and it is rigid. We can also see that the pre-image is the top one, the new image, or our image itself, is the bottom one. For this last question, we then see that it is sliding or translating, which is a rigid motion, and the top figure is our pre-image, and the bottom figure then is our image, or the new figure. So remember, when you see your original figure and the new figure, you should be able to tell me what type of transformation it is. If we know it is specifically a translation, we know that it can either slide left, right, up, or down, and translations preserve orientation, or it does not turn our figure. Translations are also isometries, or they keep the same size. Translations can be represented using a vector, words, or a rule. And a vector is a quantity that has direction and magnitude. So it tells you the direction of where it's going, plus it will tell you how far you would need to move. The initial point of the vector is the starting point. The terminal point is the ending point of our vector. So when we shift our figure left or right, we're moving it horizontally, so it's a horizontal change. And just like when we write a coordinate, that will go first because that's our horizontal difference. And then the vertical, so up and down change, will go second. We are going to see vectors written with, instead of parentheses, they're like little mini brackets kind of on the side there. So if we need to move our pre-image, so here's our pre-image and here's our image, this is where we're starting from. This would be our initial points of our vector, and then where we end up would be the terminal points. So to translate the image, the pre-image along the vector 3, 5, that means that we are moving to the right or left 3. And since it's positive, we need to move to the right 3. And our second number is a positive 5, so that would be either up or down, and that would move it up 5 units. And just like I drew in my picture, you can see that each of those coordinates then are moving to the right 3 and up 5. So the rule, then we write that as a coordinate. So our coordinate starts out as x, y, and then since we need to move to the right 3 spaces, that would be, we're adding 3 to each of the x values. And our y, since we are moving up 5 units, we are adding 5 to each of the y values. So if it was subtracting, that would mean we're going down or to the left if it's x or y. On number 1, we just need to state the meaning of our vector. So if we see it written as -3, 1, we need to be able to tell what direction that is moving. So if it's a -3, that means we're going to the left 3 spaces. And if our y value is the 1, that means we need to move up 1. So that's the state the meaning of the vector in words, but now we need to write the rule. So remember, if we are starting out as our coordinate, left 3 means we're subtracting 3, up 1 means we are adding 1 to each of the y's. So now I want you to do number 2 on your screen. This is what you should have put for both of your answers. For this last question, we need to draw the image, so it's our new figure, when we translate along the vector -5, 4. So remember, if we want to write this into words, that's left 5 and up 4. So if we actually count on our graph, we could do that as well. So if we count to the left 5 spaces, 5, and then up 4, 1, 2, 3, 4, that means that my point D is going to end up at -3, 0 right there. And that would be at D prime. So then if we move all the coordinates the same way, there would be my A prime, my B prime, C prime, and D prime then all together. So we went to the left 5 and up 4 spaces. And you might want to start getting in the habit of labeling each of those as well, just so that it's real clear of which is the pre-image and which is the image until you get the hang of it a little better.